Greetings folks and welcome to the Electromaker podcast. This is your roundup of all things maker and embedded and lovely. And it's been another big week for releases. On just the last show we were talking about the Raspberry Pi Compute Module 5 and now the Raspberry Pi 500 and Monitor have landed. The Pi 500 is an all-around upgrade from the 400, but there's a few interesting factors about it which we get into in the show. The monitor itself is a good little slimline monitor. It's relatively cheap. It can be run directly from USB, which is a very nice touch, and we get into that in the show as well. But that's not all. The Arduino Nano Matter has finally landed. It's by far the Nano I've been the most excited about getting my hands on and getting started with, and it seems like immediately after launch they already have a lot of very interesting demos of what you can do with it, not least making your own Matter devices that use Thread, but also creating your own Thread border router as well. So if you bought two of them, for example, and had an extra host processor for actually being the Matter controller like any ESP32 board, you'd be away to the races without needing any kind of Nest Hub or Alexa or any usual sort of Thread border router. We also look at a fantastic AI-enabled smart scale which allows you to work out what the macros are from food locally. You use local object detection to look, and you say, oh, okay, that's chicken, and there's 600 grams of chicken, so we know exactly what the macros are for it. That's a fantastic project from the Electromaker Projects Hub from Engineering Dads. This show is sponsored by Nordic, so you'll hear that in the show. But as always, if you would like to support us, you can also head to electromaker.io/shop. But I think that is it. Let's get on with this week's show. We are going to start this week's show by talking about two new releases from Raspberry Pi. And if it sounds like a deja vu-esque thing to say, it's because we've talked about a lot of Raspberry Pi releases lately. They've been on an incredible tear. Now, last time we talked about the Compute Module 5, which is Raspberry Pi's completely stripped down module that is just the bare bones of the computer that allows you to put it onto your own custom hardware PCB and just use whatever peripherals you need. The Pi 500 in many ways is the opposite of this, because it incorporates everything that the Pi 5 can do into a keyboard-based design. So it's like the computers of old, like Atari, Amiga types, that you can just plug into any kind of display and get started with. And this is it right here. And you still have access to things like Ethernet and the GPIO ports, because you can see on the back here there is a small slot. There is a better view of this further down the page we'll look at a moment. But the other thing that they have released is the Raspberry Pi Monitor. Now, earlier this year at Embedded World, I think it was, or it could have even been last year at this point, Raspberry Pi had these monitors on display, but in a very Raspberry Pi move. There was no further information, no fanfare. They weren't announcing it, it was just there. And I had a bit of a play around with it. They had a keyboard and a mouse and a regular Pi 5 attached up to the screen, and I just spent a couple of minutes just arbitrarily messing around, seeing how fast the browser ran, seeing what the speed was like both for the monitor and for the Pi, and it was very, very snappy and very bright. It's a 15.6 inch display, 1080p, which in my opinion it doesn't need to go any higher than that. When you have a display that small, I don't really see the utility in a 4K display. You may differ. It does also have a set of speakers in it, which I couldn't personally test at the trade show because it's just so loud on the floor of a conference. But there's something like 1.4 watt speakers. Again, we'll get into the specific specs in just a moment. But one thing of interest I want to say straight off the bat is that this keyboard can be powered via a power supply at its full brightness, but you can power it directly from the USB port of your Pi or computer of choice and get about 60% brightness out of it without needing any external plugs or anything with it, which is immediately, I think, a thing that's going to make it very attractive to people. So I got most of those numbers more or less right. It is a 15.6 inch monitor, full HD IPS panel with a 45% color gamut and an 80% viewing angle, and a pair of 1.2 watt speakers. And the fold-away stand at the back is just a piece of plastic that folds out. There's no images of it here, but that's another one of the things I remember from having it in my hands. It's quite a sturdy mount that can be folded out. And if I remember correctly, you can sort of fold it out and it will stick at slightly different angles, so you do actually have a choice of different viewing angles. There's also VESA mounts that you can just attach using the same kind of mounting that I have my monitors here attached. If you've seen those bar mounts that people use on their desk to save a bit of desk space, you can use that with these as well. And I've already mentioned the fact that it has speakers in it. It can use a range of different sample rates from 22 to 96K, I think, and it also has a 3.5mm socket for your headphones if you want to plug into it. But again, I think the thing that a lot of people will find quite exciting is the fact that you can just use the included USB to USB-C cable and power the monitor directly from the USB ports of your device, which is 60% of the maximum brightness, which is still quite bright, and 50% of the maximum volume, which is still quite loud. Or you can use the dedicated USB-C power supply from Raspberry Pi. One less plug is just a nice convenience, certainly for someone like me. And it's not the end of the world. I could, of course, just have an extra power supply and have an extra plug point. If you're an educator and you're buying these things in bulk, and you have, say a pile of Raspberry Pi 400s or 500s and a bunch of these monitors that are very slender and I imagine would be fairly safely stackable, having to have one less plug per student is going to be so useful. And it's going to make setup so much easier. It's going to be really quite a useful thing. I can see the real utility in that. And again, if you, there's, various different ways you can work with the Pi in your home or whatever. I have a Pi 400 on the shelf in the kitchen because it's the only computer that actually fits on a shelf this wide. I know that's a very specific use case, but that on the shelf and then being able to have the monitor more or less stuck to the wall would make it actually something that I would use on a daily basis. I understand that I may have said at the start of this segment, the Pi 400 was a little bit of a divisive thing when it came out, because a lot of people wondered, what is the utility of this outside of, say, education? And I mean, I think education was a very big focus of Raspberry Pi when they came up with it. But a lot of people found surprising amounts of uses for it. Which brings me quite nicely on to price. Now, the Pi 500 is retailing starting at $90 recommended retail price. The Pi Monitor is $100 recommended retail price. The Pi 400 has just received a price cut. The Pi 400 is now available for $60, where it was $70. And the personal computer kit is now $80, where it was $100. And they're also bundling Raspberry Pi branded SD cards with every Pi 400, which is a reduction in and of itself, because as we talked about when Pi brought out their own SD cards, these are SD cards that they can trust to run their system, and just one less thing you need to buy if it comes bundled with it. And the personal computer kit, if I remember correctly, comes with a mouse and a book for how to get started, and the SD card. So I suppose the saving there isn't necessarily as stark, but you do also get the official power supply from Raspberry Pi, which means you're not going to have any power issues, something that I think many of us have struggled with in the past, using aftermarket or third-party power supplies that don't necessarily give the power supply the power that you need. The power supplied? Supply the power that you need. There we go, English language. So, onto the Pi 500, and as you may expect, it is comparable to a Raspberry Pi 5 in almost every way. The actual circuit board itself is just a custom Pi circuit board, which we're going to come on to in just a moment, because Jeff Geeling did a very interesting teardown of it. But the basic stats is 2.4 gigahertz quad-core 64-bit ARM Cortex-A76 with 8 gigabytes of RAM. At present, I think this is the only version that you can get. I don't think there is a different version with higher RAM, but I may be wrong about that. Certainly my local retailer only has them at 8 gigabytes. The only reason I say that is because the store page for Raspberry Pi says these are available from $90, which makes me think that perhaps they might be bringing slightly different variations of the Pi 500 in. And again, there's a way they could do that that's very awesome, which I'll come on to in just a moment. So, a Video Core 7 GPU supporting OpenGL ES 3.1 and Vulkan 1.3, dual 4K 60 HDMI display outputs, and then Wi-Fi, Bluetooth, 2 USB 3 ports, 1 USB 2 port, and a gigabit Ethernet port, and again the Raspberry Pi GPIO connector on the back just here, so you still have access to all the GPIO ports. And if you're wondering how this can work with hats, there are multiple different adapters out there which will plug into them and turn them 90 degrees upwards, and there are even ones with stands that would stand behind the Pi 4 to take the strain off the hats. There's a lot of those. Pimoroni does a very good one. I'll try and remember to link one in the description just here. So, the Pi 500 is priced at $90, including a 32 gigabyte Pi branded SD card. So once again, they're bundling the SD cards in with the Pi 500, which saves you a few quid. And there's the desktop kit, which comes with a mouse and a power supply, a cable, and the Raspberry Pi Beginner's Guide. Now, on the surface, this is just a really big upgrade, but under the hood, things get really quite interesting. Jeff Geeling, who is Mr. Raspberry Pi as far as I'm concerned, got the Pi Monitor and the Pi 500 early, as you would expect, but he did a teardown on it and found some very, very interesting things under the hood. So this image here is the PCB of the Pi 500, and there's a couple of things you will probably notice immediately. The eagle-eyed among you will have seen that there is very clearly an M2 slot here, but there's not, because there's no actual socket for the M2 things to go into. And as the article goes into, Jeff being Jeff, got a bunch of M2 sockets and actually soldered one onto the board, and it still didn't work. There is underlying things that were required to get it working. The same can be said for Ethernet. The Raspberry Pi 500 does have Ethernet, but there's a power over Ethernet circuitry pads over here. You could actually get this thing going if you put the things onto it. Again, I'm not sure if anyone has tried that and got it working as of the time of me recording this. But yes, this is a very interesting thing, because as far as I understand it, the Pi 400 was just what it is. Whereas this is very clearly a board that is going to be able to be extended in different directions in the future. I could see a world where the Pi 500 has a second model, which is the Pi 500 Pro, which maybe has more RAM, or the choice of an M2 slot, or power over Ethernet, or all three of those things, maybe in tiers. Who knows? But it is a very interesting thing, and as always, I suggest going and reading Jeff's article on it, because I have to say, I love Jeff Geeling's videos, but I spend more time on his blog than watching his YouTube channel at this point, just because I find his write-ups to be so well put together, and again, with the life that I have and children and stuff, I spend a lot of time reading the internet via Instapaper on my Kindle in bed, and Jeff Geeling's blog is something I read a lot. He also goes through an interesting thing with the VESA monitors that I didn't even occur to me, is that the VESA mounts are great, wonderful things to have. They do somewhat get in the way of actually plugging in the 3.5mm jack. And at first I was like, that's a big oversight. But then it occurred to me, would I be plugging a 3.5mm jack headphone into the monitors if they were VESA mounted in my studio? Probably not. I'd probably be using the 3.5mm jack out if I had the Pi 500 with me with a battery pack and I had it set up on a table somewhere in public. Now, your mileage may vary. I know not everyone is lucky enough to have a separate room/studio like I do to work in. Not everyone is lucky enough to have more than one machine to work on. So when I say I can just plug my headphones into my laptop, I appreciate that not everybody has that. But it is something to be aware of. Come and have a look at this article. He goes into, the biggest gripe he has with the monitor is the VESA mount option. The plate covers the port entirely, so if you ever need to change the cable or plug in headphones, you have to remove the VESA mount entirely, which is, a bit of an oversight. One other thing which Jeff mentions in a separate blog, which again I will link here, or maybe he links it at the bottom of this blog, is that the keyboard on the Pi 500 is actually run using an RP2040 chip. And that RP2040 chip is running the popular keyboard firmware software, or firmware QMK. Which is really kind of cool, because that means that essentially this keyboard for the Pi 500 talks the same language as a lot of different mechanical keyboards do already. So someone could just take a Pi 500 and just slam a really nice mechanical keyboard on the top of it instead. Obviously not physically slam it, take it apart, use it, put it back together, a little bit of hacking here and there, and have a Raspberry Pi 500 mechanical keyboard, which I think would be incredibly cool. Yes, I will link this blog as well. This is Jeff Geeling's nice little short blog about the keyboard side of things. The RP2040 is the thing that lets the membrane keyboard of the Pi 500 talk to the hardware, and it is running QMK. QMK have a little guide as to how you can flash the RP2040 on the Pi 500 directly from the GPIO pins without having to do anything. I think it's all internal. Yes, that's right. Okay, with the boot select, which can be triggered through the GPIO pins on the Pi 500. So you can literally do it like any other Pi, but instead of actually having to do anything with the chip itself, you can let the GPIO pins trigger the boot, and then you can drag the new firmware onto it that way. So as Jeff says here, since it's obvious the Pi 500's PCB is going to be able to do other stuff like power over Ethernet and have M2 slots eventually, could we see an enthusiast-grade mechanical keyboard version of the Pi 500 with all bells and whistles? And as he mentions, he's already been asking System 76 if they might consider designing a bottom plate for this, which is the System 76 launch keyboard, which does look very lovely as well. Anyway, I've talked about Pi 500 and enthusiastic things about it in the monitor for a little longer than I meant to. I am very interested to hear what you think of the latest iteration here, the Pi 500. Again, the Pi 400 was a bit divisive. There were some folks that said it was a real waste of money, there's no point in it, and people always have opinions about this kind of stuff, but it does seem to be one of the ones that people really do. Some people scratch their heads and say, why does this exist? And some people are kind of like, this is the coolest thing in the world, I would like one. And I'd really like to know where you stand on that kind of scale. We're going to move on to the Arduino Nano Matter, which is again another hotly anticipated development board, and we talked about it quite recently. One of the preview boards was used to run Quake natively on a piece of silicon that you would not expect it to be able to run it on. But the board itself is now available, and it is really quite an exciting one in my opinion. So the Silicon Labs blog here I think covers it quite well. The basic gist of it is saying that this looks like a Nano, but this is not your ordinary Nano. Much like some of the Arduino Pro boards are sort of being priced down to be available to more people, and the documentation for it is getting up to the point where people who are more versed with regular Arduinos will be able to use the Pro line. This moves in the other direction. Much like the Arduino Giga is an incredibly powerful, large-scale upgrade for the Mega that could be used in a Pro setting, the Nano Matter is something that isn't necessarily just for hobbyists and enthusiasts, but something that could be used in the industry as well. However, from my end of things, I am absolutely a hobbyist and enthusiast as the non-engineer who loves tinkering with things, and I am very, very excited about this board. I am going to be getting my hands on 2 Arduino Nano Matters, and there is a very specific reason for that, which we'll go into in just a moment. But yes, if you want to know the more technical side of it, of course, Silicon Labs, who have partnered with Arduino, it's their hardware on the device. I'll be linking this blog in the description, but I'll also link through to things like the Arduino side of things, because you can see it in the shop. If I remember correctly, it's around about $20, $21.90, euros, 21 euros and 96 cents. For some reason, I thought I was in the American shop. Yes, so you can get a hold of these now. These are now available. But as I said, I will probably be getting my hands on 2 of these things for a very specific reason. Now, as soon as this board was released, I jumped straight to the documentation for it and saw what examples and things exist for it. And it's pretty much going to do exactly what I want it to do, because let's start with a very simple example. This is a Matter Smart Relay, and essentially you have on the hardware side of things an Arduino attached to a small relay module. I'm very much in the way here, let me make myself smaller. An Arduino board, the Matter board, attached to a 5-volt relay module, and this is attached to a light bulb. I think many people will have fiddled with something like this at some point in their Arduino journey. But this shows how easy it can be to attach it to the Matter protocol via something like a Google Nest Hub if you have one, or an Alexa, and if you do have that, you'll find it very easy to get up and running, because Matter works basically by QR codes. You set this all up in the Arduino IDE, it will give you a link in the serial monitor, you open it up, and you scan that in your app of choice. I guess it's Google Home? Yes, Google Home. You can tell that I don't really use much proprietary smart home stuff by the fact that I forgot what Google's app was called. However, I did used to be quite into these proprietary smart home stuff, because I used to write about it and do tutorials about it way back in the day. And I always loved the concept of an Alexa or a Nest Hub or a Google Home. But I always wanted to be able to do something a bit that was my own thing, right? So I've messed around with open source voice assistants on Raspberry Pi in the past, for example. And as we've shown on the Electromaker Show recently, Robin has had 2 product of the weeks that had dual microphones in them, which are designed for, yes, some directional audio, but also comparative audio to allow your voice to be heard over music playing out of a nearby speaker. So you could get the voice side of some kind of voice assistant working. But this project, combined with another one, the Open Thread Border Router, essentially would allow you to do most of the work that you would need to control your smart home without any of the actual hardware required, the proprietary hardware. So this is a much more in-depth tutorial, and I'm really glad that Arduino have put it on the docs. This requires two boards, a Nano Matter board and an ESP32 Nano board, although having read through the tutorial, I'm almost certain you could use any ESP32 board for this. You just have to make sure that you put the relevant pins for sending and receiving over UART into the configuration documents that are in this tutorial. And essentially, the Matter controller, the Nano ESP32 here, talks to the radio coprocessor, which is the Nano Matter over here, and tells it how to be a thread hub. You can make your own edge thread router. And if we go down just a little bit further, there's another image that sort of shows how these things are going to all fit together. This is all just going through, by the way, how to work with Silicon Labs software to flash the Nano Matter. We're out of Arduino IDE land now, using the IDF to actually set the target for the ESP32. Oh, and again, I think this is literally all you would need to change to get it working with pretty much any ESP32, but don't quote me on that. I haven't looked at the memory requirements for a Matter controller, for example. And then, yeah, you have this original idea we had. So the chip tool is what you would use on your computer to control the thread system. And this, look, does this look familiar to you? This is the original tutorial we had just here of a little smart relay fitting into it, completely cutting out the need for a Google Home or an Alexa or any of those things. I keep saying a Google Home. Google Home is their software. The Nest is their hardware. Anyway, I have gabbled on enough about this, but I think you can see now why I said I'm going to be getting two of these things, because to start really coming together with the idea of how something like this could work, I'm definitely going to want to try and emulate this project and then see how that could fit into a smart assistant. It's a project I've had on the back burner for years, but this has really reignited this idea of saying I really could do all of this in-house, have something which is a completely offline device that is just trained to listen to a few phrases and words and can speak to the internet when you want it to, but won't necessarily send everything you say to someone separate. I'm not a particularly paranoid person that Google or Alexa is listening to everything I say, not because I don't think that's the case. I just think we're beyond the point where it matters particularly, but I do really like the idea of having hands-on control and understanding how all of these protocols work, and this seems like a really nice piece of the puzzle, at least for someone at my level of engineering, to be able to really get into the weeds and get something up and running. As always, I'd love to know what you think, but the short news is it is now available for $21 or 21 euros and 96 cents, and I will leave links to everything I've just talked about in the description of this video. This show is sponsored by Nordic Semiconductor. Thank you, Nordic, once again for sponsoring us. This is usually the part of the show where I say we don't get sponsors, so thank you for shopping at our store, but yes, Nordic, thank you so much. Today, we're going to focus on the Wi-Fi offerings that Nordic have, because it's quite interesting. Wi-Fi was the thing that Nordic did not do for a long time. Nordic have been known for industry-leading Bluetooth Low Energy devices and more recently cellular IoT devices, and both of those things are essential for the Internet of Things, and what they both have in common is that they're capable of doing quite a lot, but with a very low energy draw. You can have these things running on battery power, and of course cellular works anywhere where you have cellular connectivity. Bluetooth works anywhere where you have Bluetooth enabled devices. Wi-Fi never really fit into that, and that wasn't necessarily down to the fact that Nordic weren't capable of doing it, just the technology wasn't there for it to gel with the rest of those protocols in the same way that they wanted it to, until Wi-Fi 6 came along. Now, there's a number of advantages for Wi-Fi 6, and it's out of scope of this sponsor message to go into them, but essentially Wi-Fi 6 is kind of there now. It's using a low enough amount of power for it to be a credible use of a credible Internet of Things protocol, put it that way. Interestingly, Nordic came onto the scene with the nRF7002, which is their first non-host device. This is an IC that will work alongside one of your host devices. And let me jump straight in and say the nRF7002 DK is, to me, kind of pound for pound one of the best value development kits you can get from Nordic, because you're getting the nRF5340, which was until recently their flagship Bluetooth Low Energy chip, built in as the host controller to the nRF7002 DK. And the board breaks out absolutely everything that it can do. So this is a really good start. There's a fantastic getting started guide from Goliath as well if you want to use their online service. And Nordic's in-house getting started with the NRF Connect SDK is, I have said many times, not only one of the best tutorials for getting someone like me up to speed with an industry standard toolchain, it is also a good half step into Zephyr, the toolchain it is based upon. If you would like to find out more about how Nordic got into the Wi-Fi game, as it hardware, and everything else there is to know about Nordic's products, do head to nordicsemi.com. There you can find a full list of their product catalogue, whether you're looking for a specific IC or just looking by category. Like I mentioned, cellular IoT is one of the categories, but there are various chips under that category. The newer ones move into things like DECT NR+, and they have devices that work with Thread, Zigbee, ANT, everything that you would want to use as a communication protocol as part of your design. And each one of these things has a development kit that represents it too. And just to put it out there as well, I haven't mentioned in these sponsored messages so far, but Nordic also have their entire own range of power profiling software and hardware in the power profiling kit and the NPM fuel gauge, both of which can do very high automated tests on your power setup, and do things like battery emulation and things like that as well. If you'd like to see an example of that, we actually have an example from the floor of Embedded World earlier this year. I'll try and remember to link that in the description. But for now, nordicsemi.com. Thank you so much, Nordic, for sponsoring this episode. We are going to close out this week's show by looking at a project from Engineering Dads. This is a AI smart scale where it doesn't just weigh food, but it looks at the food, identifies it, and then gives you a macro breakdown of that food based on the weight of it. It's a really neat and kind of interesting idea, and not one that I've seen in a commercial product yet, unless I'm just missing it, but it seems like a real shoe-in for how AI could be used in a really effective way to help people in their day-to-day life. But that said, this is very much a prototype. So, what do we have here? We have essentially a scale on the bottom, which can weigh, in this case, a bowl of pasta, but a camera over the top looking over it that says, okay, that is pasta. So we know it's pasta from AI inferencing, and then we know the weight of it, and so you can combine those two things to give an accurate model of the calories that you will be getting and the macros you will be getting from those calories, exactly how it is broken up. Now, there is, as always, a fantastic video to go alongside it. There always is with the Engineering Dads projects. They've got a fantastic YouTube channel that really does deserve to have more than just over 1,000 subscribers. So please do go and give them a subscription. Just a quick reminder, any video you see embedded into any of our pages, if you just click on the video title, it will take you straight to it, and it will allow you to subscribe to it there. And this will take you through the entire project in video format. If you want just a very quick rundown of it, we're looking at two Raspberry Pis here. We have a Pi 0, which is actually on the thing itself, and we have a Pi 4 as the hub, because they're actually doing this all locally. You could imagine a commercial device like this would maybe use the cloud. It would send data to the cloud, and then would get, that's how they would do their AI inferencing. This is a custom trained local model using TensorFlow. Is it TensorFlow Lite or TensorFlow? I've actually forgotten that already. A trained TensorFlow Lite food recognition model runs on a Raspberry Pi 4 Model B, which is the hub of the device, and then you have the actual Pi W here, which is taking the pictures of it, and you have a screen here which says, look, you've detected a chicken breast, and the weight of it plus the macros will the weight of it plus the recognition of it allows you to give those macros based on a database, because macros don't really change between things. All you need to know is what it is and whether it's cooked or not. Now, this is clearly a proof of concept. You would need to train a local model on a huge amount of things for it to be effective. And as I've said, I could imagine if a company turned this into a commercial product, they'd probably skip that by just having it something that has to be connected to the internet to work. But in terms of a proof of concept, it really is quite wonderful. It is all available right here. You can head through to the video to see the full description of the video and a full technical rundown of the build. That was our show for this week. Thank you so much for joining me. Thank you for your continued support, and thank you, Nordic Semiconductor, for supporting us by sponsoring this show. It's been wonderful to actually finally get a little bit of sponsorship on some of the shows. It's been a point of pride that we've been able to do this pretty much off our own back, but it is nice to be sort of noticed for the work that we're doing as well, so thank you very much. I will be back with another podcast next week. Until then, I hope you have a safe, fun, and creative week, and I'll chat to you then.